To quickly summarize what we've learned about exponential relationships today, we know that a relationship in the form of y equals a times b to the exponent x, that this is going to be an exponential relationship. Okay, the b value has to be bigger than 0. Okay, and we know that the b value cannot equal 1. Okay, it can be any other number, but it cannot equal 1. Okay. So we also know that if the b value, in the second bullet part here, if the b value is bigger than 1, then moving from left to right, the graph increases very slowly for negative values of x and increases more rapidly for positive value x. So this graph is increasing in value. Okay, so it is increasing in value. So it's almost horizontal to the left of the y-axis, and it's very steep on the right-hand side of the y-axis. If, however, the b value is between 0 and 1, so not equal to 0 and not equal to 1, but in between them, then moving from left to right, the graph decreases rapidly, okay, for negative values of x, and it decreases more slowly for positive values. So this is an example of a decreasing curve. Okay. The next thing is that the y-intercept is always equal to the a value. So whatever that a value is, that's going to be the y-intercept. So let's say we had an equation y is equal to 150 times 2.5 to the exponent 7. This means that my y-intercept is going to be 150. Okay? There is, for exponential relationships, no x-intercept. Okay? There's never an x-intercept because the numbers, they approach 0, they get close to 0, but they never actually get to 0. Okay? And so the growth or decay rate, i.e. how fast or how slowly a curve is moving, is always determined by the b value. Okay, so in general, the bigger the value of b for increasing values, the faster it increases. The smaller the value of b for decreasing values, the faster it's decreasing. Okay, so the b value is the rate of decay or the rate of growth. Okay, it just determines just how quickly that curve is going to be going. Okay, so if you have, a curve that goes very high, your b value is going to be bigger than a curve that goes like this. In this case, the b value is not quite as high. So the b value is still going up, but not going up nearly as high. Okay, and similarly, if you have a b value that's decreasing in value, if it's very steep, then the b value is very low. But if the b value, if it's a more shallow decline, then the b value is not quite so low. Okay, so that is a summary of exponential relationships and curves as we've learned them to this point. We're going to be making use of analyzing the a value and the b value quite often going forward. So those are important concepts for us to drill into our heads and be well aware of.